have a question to ask because I got a feedback from someone. Do y'all feel like I'm going too fast by any chance? Do y'all feel like I'm going too fast? Anybody? Or is this speed okay? If this speed is okay, can y'all give me a thumbs up? Right. Okay. All good then. I hope it's not. I mean, I also don't think that it's too fast, because if we are not going at least at this speed, I don't think we'll be able to finish the syllabus. But I make sure that you understand, and we do a lot of exercises. So I hope this is okay. But if you have any feedback, you can let me know. එතකොට AK, J, K and L. AK, J, K, L, J is P squared. Minus 12P plus 35. Now you guys know the drill, right? What do? We take the first term is P squared, you multiply it by last term 35, you get plus 35P squared. Then you are going to see how this can be formed. අපිට පුළුවන් 7 times 5. So 7P multiplied by 5P. So plus 7P multiplied by plus 5P, we get plus.
Excuse me, miss.
Yes, Ismail.
You are seeing the J in 7.1.
7 point. I'm sorry, what? 7
You
point.
are this
Yeah.
J P2 minus 12P plus 35 is from
7.1.
Yeah, it's from 7.1.
Right, okay. Homework is from 7.2. Yeah, right. Okay. Now I got it. I'm very sorry. ඒක තමයි සවින්දුත් කිව්වේනේ මට කෙච්චර note උන්නේ 7.2 එකේ JKL, right? Am I right?
Yes, yes.
Okay. 7.2 first එකේ A එකේ A එක දුන්නේ නැහැ මං හිතන්නේ සවින්දු. I gave JKL. JKL last තුන තමයි මං දුන්නේ මට මතක විදියට. So we have 2m squared plus 3mn minus 12 minus 2n squared. We will be done with this lesson today. Good for us, so that we can move on to the next one. So we are going to multiply the first term and the last term. Here we have 2m squared. Here we have minus 2n squared. 2 times 2 is 4. M squared, n squared. This is plus, this is minus. Plus times minus is minus. We are going to see different ways how we can produce this, right? You know we can make this by 4 multiplied by 1. So 4mn multiplied by 1mn. Since the answer is minus here, different signs multiply when done. So plus 4mn multiplied by minus 1mn, or minus 4mn multiplied by plus 1mn. Then if we add and check, මෙතන plus 4mn minus 1mn, we get plus 3mn. Here minus 4mn plus 1mn, we get minus 3mn. What do we want in the middle? Plus 3mn. එහෙනම් අපි මෙන්න මේ දෙන්නව තමයි ගන්න. Plus 4mn and minus 1mn. So 2m squared plus 4mn minus 1mn minus 2n squared. Now we'll find the common elements. If you take the first two, 2 is common, m is common. When I take it out, 1m is remaining. Here 4mn වලින් 2 ගත්තාම 2 remaining. mn වලින් when I take m out, n is remaining. Here we can take minus n, right? We can take n out. Then we have m remaining and we have plus 2n. Because minus times plus and minus n, isn't it? So therefore, the answer is m plus 2n, 2m minus n. Is this clear to all of you, Lamai? Okay, great. Well, let's discuss all the three and then I will give time for corrections. Then we have k. No, okay, right, okay. Then you can do corrections here really fast. I'll give you 1 minute, quickly do the recorrections. All right, Lamai, let's move on to k. K වල තියෙන x squared, y squared. Regarding that, we are actually doing the 7th lesson now. So I think towards the end of April or beginning of May වගේ තමයි අපි second term පටන් ගන්න, right? So still we're doing the first term lessons. So x squared, y squared plus 10xy plus 16. All right. You take the first term and the last term, you multiply them, right? So first term is x squared, y squared, last term is plus 16. When you multiply, you get plus 16 x squared, y squared. There are different ways how we can produce this. 1 times 16 is 16. 2 times 8 is 16. 4 times 4 is 16. Here, බලුවමත් පේනවා 2 times 8 කියන එක තමයි අපිට ගොඩක් එන්නේ. So, I'll just write this, right? 2xy multiplied by 8xy, we get 16xy squared, right? So, this can be plus 2xy multiplied by plus 8xy. or it can be minus 2xy multiplied by minus 8xy. Okay. Then we are going to add and check. Plus 2, me tava kek options thiyanwa, but since I have an idea that it will be one of these, that's why I'm just using one of these, right? Plus 2xy plus 8xy. 2 times 8 is 16, x squared, y squared. Plus times plus plus. Here, minus, plus times plus neve, metana plus tame answer kenne. Minus 2xy minus 8xy. Minus times minus plus. Minus times minus plus neve, sorry. Again, I got it wrong. Multiplication, we are going to do the addition here, right? I'm sorry. So we get plus 2 plus 8 is 10. So 10xy. I'm really sorry. I hope you didn't get confused, right? Minus 2 minus 8 is minus 10. And again, we have xy. If you look here, we have plus 10xy, right? And now we have to use this. Plus 2xy and plus 8xy. Plus 2xy plus 8xy plus 16. It's okay. Markarata kamakne same thing answer kena. In both these x and y are common, so I will take xy out. Then here x and y gatham ek x ekui y ekui idurena. Here from 2xy when I take x and y out, 2 remaining. Here 8 is common. When I take 8 out, I have xy here. I have 2 here. So I have xy plus 2 and xy plus 8. Did you all get this answer, Lamai? Okay. Then I'll give you time for recorrections. 2x cube multiplied, minus x squared y minus 3xy squared. Now let's stop here for a second. We have x cube. Mokada karandang x cube bava. Because so far we have not learned anything regarding cubes. We have only learned square. Then what do I do here? What do you think I should do here? Any ideas? Because this format we have not learned, no. Right? Cube so cube yes, that's a good one. That is what I'm going to do. I'm going to, because here there's x here, there's x here also, there is x. So I'm going to take x out because it's common. So I take x out. 2x cube being x I get 2x squared. X squared y again, when I take 1x out, I have xy. Minus 3xy squared getting x wahama, we get minus 3y squared. That x let x be outside. We are going to use 2x squared minus xy minus 3y squared for our factorizing. Okay. Let's see. This is the first term. This is the last term. We'll multiply. 2 times 3 is 6. Here this is plus. Plus times minus is minus. Here x squared. Here y squared. Now we have to see all the different ways how we can make this, right? 1 times 6. 2 times 3. Right? So I will use 2 times 3. 2xy multiplied by 3xy. Since here the answer is minus, different signs have to be multiplied. So it should be either plus 2xy multiplied by minus 3xy or minus 2xy multiplied by plus 3xy. Balu making now we have to add no plus 2xy minus 3xy, we get minus 1xy. right? We get minus 1xy. Minus 1xy is just minus xy, right? Here, minus 2xy plus 3xy, we get plus 1xy or just plus xy. Here, what do we need? We need minus xy. And now we have to use these two, plus 2xy and minus 3xy. So, plus 2xy minus 3xy minus 3y squared. Now, if you take the first two terms, 2 is common. So, I take 2 out. X is common, so I take x also out. So, 2 is common, x is common. From 2x squared, when I take 2 and 1x out, there is 1x remaining. From 2xy, if I take 2x out, there is 1y remaining. Then if you take these two, then another minus 3 is common. And both of them have y common, so I take them out. Minus 3xy again, minus 3y gathama, we have x remaining. And from minus 3y squared, if I take minus 3y, I have plus y remaining. So here we have x plus y 2x minus 3y. Finally, we don't really have to put the square bracket. You can just write it like this. Is this clear to you, Lamai? Okay, quickly do the recorrections. Make it fast. That's okay, Savindu. The only thing is that you have to, of course, combine. The methanol there is 1x and methanol plus y. So then our combine karama, you get this x plus y bracket. And the other bracket is 2x minus 3y. Is it clear? If you don't combine, you don't get the final answer. Anita, Lianakan, can somebody tell me what is our other homework? Do we have any other homework? Okay, so we did difference of squares. Ne? Did we finish the lesson last week? Okay, great. That's great. Okay, from 7.3, quickly tell me what our homework questions are. Two Hij. Two Hij. All right. Two Hij. Okay. Exercise 7.3. Second question. And third one. Okay. H. H is 400 minus 4n squared. I told you last week for you to be able to use difference of two squares, always remember everything has to be in the square form. For example, 400 we know it's 20 squared. 20 times 20 we get 400. 4 is 2 squared and n squared. 20. So we open two brackets. From 20 squared, 120 goes here, the other 20 goes here. 2 squared, 1, 2 comes here, 1, 2 comes here. From n squared, 1 n go here, 1 n goes here. So for this I put plus, for this I put minus. Did you all get this answer, Lamai? Did you all get this answer?
Yes, miss.
Yes, miss.
Okay. Did you understand? Those of you who didn't get the answer, did you understand? Savindu? Let me know if there's anything you don't understand. Then we have I. I can 8x squared. 8x squared minus 2. Now there's a little bit of a problem here. Is 8 a square of something? Is 8 a square of something? Yes or no? Quickly tell, is 8 a square of something?
Four.
No, 4 squared can is 16. Savindu, this is wrong. You can't take 4 out like that. So if you take here 4 out 100. Right. Okay, that makes sense. Okay, that's a good approach. Chutta mangeka discuss karanna how Savindu has done it, which is also very correct. He has checked here and seen that 4 is common, so 4 elliot again. From 400, when you take 4 out, we have 100. From 4n squared, when you take 4 out, we get n squared. Now, difference of two squares we know 100 is 10 squared minus n squared. So, ek apidanawa 10 plus n, 10 minus n. Both are correct. Okay, good. Okay, coming back to this, 8 is not a square of anything. Is 2 a square of anything? Is 2 a square of anything? Yes or no? 2. No, 2 is not a square of anything. 2 can any number when you square it, do you get 2? No. When you square in like usually in our perfect squares, 2 is not a perfect square. So 8 is not a perfect square. X squared is a perfect square, but 2 again is not a perfect square. Then what I'm going to do is I'm going to take 2 out of both these because 2 is common here. 1 2 earlier to go, 8x squared when I take 2 out, I get 4x squared. From 2, when I take 2 out, I have 1 remaining. Now we can see. You know 4 is 2 squared. X squared minus 1 is 1 squared. Now we can easily put them into 2 brackets, right? So I'm going to open 2 brackets. 2 squared, 1, 2 I put here, the other 2 I put here. X squared, 1x I put here, the other x I put here. From 1 squared, 1 I put here, the other one I put here. So here plus, here minus. This is how you factorize this expression. Did you understand this? Did all of you understand this, Lamai? Give me a thumbs up. Give me a thumbs up if you understood. What about others? Lamai, can you all hear me?
Miss, you are lagging.
I'm lagging. Okay, 1 second. Let me check.
Miss, you are lagging.
Okay, wait 1 second. I'll check. Lamai, can you all hear me now?
Yes, miss.
Now not lagging. No, if I'm lagging again, please tell me. Okay. Then J. 4x squared y squared minus 9y squared. Everything is a square. So we know 4 is 2 squared, x squared, y squared, minus 9 is 3 squared, y squared. So give me 1 second, Lamai. Okay, I'm sorry, Lamai. All right. So here we open 2 brackets. From 2 squared, 1, 2 comes here and the other 2 comes here. From x squared, 1x comes here, the other x comes here. From y squared, 1y comes here, the other y comes here. Then from 3 squared, 1 3 comes here, the other one comes here, y squared, and we put plus minus. Is this clear, Lamai? All right. Elongator, what is the other one? Third question I gave, no? All right. So let's get to the third question real fast to the whiteboard. I think, Samindu, did you take the y squared out? Because it's common. I mean, it's not wrong. It's correct. Y squared value taragena. So you get 2x plus 3 and 2x minus 3, right? I suppose that would be all right. Nobody can mark it wrong, of course, because that is correct. I was wondering if it's a good practice overall. But yeah, it's okay. So a little something that I would add here is that in the case of like, if you are able to make it square, better to just put it in the difference of two squares brackets. Then for an example here, these are clear. 400 is clearly a square of something. 4 is clearly a square of something. So you can just directly put these two brackets. So it's better to just go like that, right? Just a suggestion. But if you take a case like this, where this is not a square, this is not a square. In a case like this, it's okay to take the common thing out and then find the difference of two squares. But I feel like in other instances, if it's possible to directly go for difference of two squares, I feel like it would be better. But anyhow, I will just check and get back to you, Samidu, regarding that. I mean, it's not wrong, huh? By any chance, by no chance is it wrong. So it's not wrong at all. I was just wondering what would be the better practice, but it's okay. All right. The figure depicts two concentric circles. Concentric ekama center ka thiyena denna. Okay. They both have center O. The radius of the smaller circle is R. The radius of the larger circle is A. Okay, this is not that difficult. Express the area of the smaller circle in terms of pi and R. So smaller circle is this name. And the radius of the smaller circle is R. And then we know area will be pi R squared. Then if you take the larger circle, the radius of the larger circle is A. Then the area will be pi A squared. Okay. Write an expression for the area of the shaded region in terms of pi R and A. Bana lamai, how do you find the area of the shaded region? If I want to find the area of the shaded region, I take the area of the big circle. From that, I have to subtract the area of the small circle. Is that clear, Lamai? You take the area of the big circle and from that you subtract the area of the small circle. Is that clear? Yes. Then what do we do? Area of shaded region equals, you take the area of the big circle, which is pi A squared. From that, you subtract the area of the small circle, which is pi R squared. Now, what does the question say? Represent it as a product of two factors. That means brackets we have to represent it as a product of two factors. Okay, can you see that in both these terms, pi is common? May I get pi thiyena, may I get pi thiyena, so I take pi out. When I take pi out, I have A squared minus R squared. How do I factorize A squared minus R squared? How do I factorize A squared minus R squared? Lama, please talk. Huh? Why are you so silent, so inactive? Only a few of you actually talk and respond and give answers. Homework is a discussion, I told you, right? I need your feedback, I need your input, I need to check if you have actually done the homework and whether you actually understood, right? So this is difference of two squares, yes. What I do is I open two brackets, A squared and R squared, ekakata plus dana anith ekkanata minus. This is how we get it. Is this clear, Lamai? Others? Alia, Ismail, Joshua, Sandaru, Savindu, Shana, Shweta, Venuja, Zuha. Is it clear?
Yes, miss.
Okay. All right. Excuse me. I'll give you 1 minute to do the corrections. Make it fast. Is that all the homework I gave?
Miss, you gave him 7.4 also.
7.4, which one?
H and I.
Only H and I?
No, H, I, and J.
H, I, and J. Okay. Quickly do recorrections, then we'll jump to that. Is that all? After that, is it all?
Yes, miss.
All right. Okay. All right, Lamai. Then let's move on to exercise 7.4. H, I, and J, right? Okay. Let's see what is H. 16 minus m plus 2 squared. 16 minus m plus 2 squared. Okay. Now, this is also quite easy because this is again difference of two squares. So, we need both the terms as squares, right? So, m plus 2 squared is anyways a square term, so no problem. But 16, we have to convert it to a square term, and that's easy because 16 is 4 squared. Then I open two brackets. In this case, I open square brackets. Otherwise, it will be a bit confusing. I put 1 for here, 1 for here, 1 m plus 2 here. The other one here. Here it's plus, here it's minus. Now let's simplify. 4 plus times plus plus, so plus m. Plus times plus plus, so plus 2. Here 4 minus times plus is minus m. Minus times plus is minus 2. So here 4 plus 2 is 6. So I have 6 plus m. Here 4 minus 2 is 2 minus m. This should be your final answer. Is this clear, Lamai? Others, give me a thumbs up if you understood this, if you got the answer or if you understood. All right, then I. M plus 2 squared minus m plus 1 squared. M plus 2 squared minus m plus 1 squared. Okay. I'm going to open, these are anyways two square terms, so there's nothing much I have to do. So I will open two brackets. m plus 2 square dwelling, ek m plus 2 ekak here, the other m2 plus here, m plus 2 here. Then from m plus 1 squared, 1m plus 1 I put here. The other m plus 1 I put here, and then here I put plus, here I put minus. So m plus 2, plus times plus is plus, plus times plus is plus. Here m plus 2 minus times plus is minus, minus times plus is minus. So what do we have here? Here m plus m is 2m. 2 plus 1 is 3. Here plus m minus m cancel veනවා. So 2 minus 1 is 1. So 1 you don't really have to put. You can just leave it as 2m plus 3. Is this clear? Others, give me a thumbs up if it's clear. All right. What about others? Okay, great. Then J. 2x plus 3 squared minus x minus 2 squared. So again, I open two brackets. Here 2x plus 3. Here also 2x plus 3. Here x minus 2. It's x minus 2, no? Yes. And here also x minus 2. Here I put plus, here I put minus. So then what do I have? 2x plus 3. Here plus times plus answer is plus. Plus times minus answer is minus. And then here 2x plus 3. Minus times plus is minus. Minus times minus is plus. Okay. Then here 2x plus x is 3x. 3 minus 2 is 1. Here 2x minus x is 1x. Plus 3 plus 2 is plus 5. So you get the answer like this. Is this clear, Lamai? All right. I'll give you 2 minutes for recorrections. Make it fast. Quickly do recorrections. Make it fast. Okay, Lama. Can you all mark the homework from, do we have any homework from previous lessons, Lama? Do we have any homework from the previous lessons?
No, miss.
All right, that's great. Then mark D, E, F, G, H. Miscellaneous exercise, huh? And then in the second question, CD. From this lesson, these are your homework. Okay, Lamai. So what is our next lesson? After this, we have triangles, right? So triangles means we are jumping to geometry. We have done one geometry lesson before this, and that was congruency. And if you remember congruency also, in congruency also, we talked about triangles, right? So we learned about, sorry, Savindu? You mean next week? Next week, you will not be having classes. Okay, 15th April, good thing that you asked. You will not be having classes. 14, 13, 14, 15 classes. Grade 11 night on 13th. 13th morning, they have a maths class. They usually have the maths class at night, but I made it morning because grade 11, your seniors cannot really afford to miss lessons. That's why. But for y'all, it's okay. And it's anyways the Urdu few days. So definitely next week will be a holiday for both science and maths. Okay. Right. Anyways, triangles. So congruency, we talked about how we can make two triangles completely identical. We called it congruent, right? And under that, we learned three cases. We learned about SAS, we learned about SSS, we learned about AAS, and then we learned about RHS. Okay. So before we talk, so again, now in this lesson, we are going to be talking some other things about triangles. So before we go ahead with this lesson, what are the different types of triangles that you know? What are the different types of triangles that you know?
Isosceles triangle.
Okay, isosceles triangle. What kind of a
Equilateral
triangle is
triangle.
isosceles triangle?
All the sides are equal.
In isosceles?
All the angles.
No.
In isosceles, only two sides are equal.
Two sides. Yes. Two sides or two
And
angles
in
are equal.
equilateral triangle, all sides are equal and the angles.
Okay. Equilateral means all sides and angles are equal. Good. Good. Zuha, Basma, Ismail. Good. Huh? Then what is the other type of triangle where none of the sides are equal? All three sides are different. You know this term. What is a triangle where all the sides are different? We call it scalene. Equilateral means all sides are equal. Isosceles means two sides are equal. Yeah, scalene means all the three sides are different, right? So then, in addition to that, we can also make triangles like acute angle triangles. That means all the angles are acute angles. Then there are certain triangles called right angled triangles where there is one right angle. Then there's another type of triangles called obtuse angled triangles where there's one angle which is an obtuse angle. We'll talk about these things in the future. But yes, So something interesting about triangles is that now there are so many shapes, right? There's circle, there's triangle, there is square, there is rectangle, there is parallelogram, rhombus, trapezium, pentagon, hexagon, octagon, heptagon. All these shapes are there. However, it is considered that from all the shapes, right? From all the shapes, triangle is the strongest shape ever. If you really like notice in most of the like constructions, in bridges, in towers, in certain buildings, they incorporate triangles a lot. Triangular shapes, structures, like Samarla to Ugulang. I mean, if you think about it now, you may not properly remember, but when you see a certain structure, pay closer attention and you will see that there are plenty of triangles around you. So in mathematics, something that we consider is that triangles are like the strongest shape. They don't easily like bend, they don't easily collapse. Yes, yes, yes. පාලම්වල. ඇව පාලම්වල තියෙනවනේ අර වැට වගේ. So ඔයගොල්ලන් ගත්තොත් එimhe නිකන් අර ලොකු bridges ගත්තොත් එimhe ඒගොල්ලන්ගේ වැටේ මෙහෙම වැට කියන්නේ like අර දෙපැත්තෙන් තියෙන කෑලි දෙක. So මෙහෙම ලොකු structures තියෙනවා. ඒව ගොඩක් triangles associate වෙලා තමයි තියෙන්නේ. Good observation, right? So again, the triangles are an interesting shape එකක්, and we talk about triangles a lot, and we are going to learn about triangles a lot too. So it is also said that how many sides are there in a triangle? Three. Three sides තුනකට වඩා අඩු. There cannot be any shape where there are sides that is less than 3. So therefore, triangle is the shape with the least number of sides. That is also quite interesting. So in grade 11, we are going to be learning something called Pythagoras theorem. You already know Pythagoras theorem, but we are going to be learning further about it. And then we are going to be learning trigonometry. It's a different lesson. All of these lessons use triangles. So another interesting thing about triangles is that, Lamai, these triangles are used so much that you sometimes, like, I mean, you would wonder, really, instances like in high-end technology, like, GPS, in satellites, in like engineering concepts, and like even in what do you call, like computer software, in certain animations, they use triangles a lot, and mathematics related to triangles, right? So triangles are super important, and you may even have seen, never, you probably, I'm pretty sure you have seen pyramids. Pyramids is like one instance where like triangles are associated, because even from the ancient times, they have realized how important triangles are. So pyramids, Godak Egyptians, they have studied triangles. Also, like there was a certain civilization in the ancient world, we call them Babylonians. So Babylonians also have studied about triangles a lot. So triangles are like super interesting. The more you learn about it, the more interesting it gets, right? So I just wanted to let you guys know that what we're learning here. So sometimes you may wonder, if you are not planning to do maths for A-levels, a question that most students ask me is, why learn all this? Like, why learn all the geometry? Why learn all the algebra and all of that? But sometimes you may not even realize it, but this is everywhere in our day-to-day life. You don't really have to be an engineer or a mathematician or a physician to know maths. Okay. So can you all put the topic triangles 1? Triangles 1. Yeah, it is a main topic. It's the name of the lesson. So like sometimes mathematicians, something that they used to say is that triangles run the world. This sometimes mathematicians have used to say that the triangles run the world because triangles are everywhere. Okay. Now we are going to be talking about, in this session, we are going to be talking about certain theorems, right? If you remember, in the congruency, we learned 4 theorems, right? SAS, SSS, RHS, and AAS. So these theorems, what we say as theorems are actually sort of like rules in mathematics, right? In mathematics, there are certain rules. So let's say you're like driving or walking on a road. So there are certain road signs and there are certain symbols, certain terms on road signs. Those are a set of rules, right? Or like standards that you have to follow when you're going on the road. Just like that, when you're like when you're involved in mathematics, when you're using triangles, there are a set of rules called theorems, right? So in this lesson, we are going to be in both triangles 1 and triangles 2. We are going to be talking about some theorems. Okay. So, මාතක මේක ලියා ගන්න. Excuse me, ළමයි. Quickly write this theorem. The exterior angle formed when a side of a triangle is produced is equal to the sum of the two interior opposite angles. So this is a theorem. As I said, theorem is a rule. So this is some sort of a rule. Okay, let's learn about this. So I'm going to draw a triangle like this. This is a triangle. I will label this triangle as A, B, C. Okay, these are the 3 vertices of the triangle. Now, my exterior angle means when you extend or when you produce one side of a triangle. For an example, let's say the side BC. This is side BC, right? If I extend this side, angle, I call it the exterior angle, right? Or, so let me show you that BC side. If I like produce it or extend it like this, the angle that it produces is an exterior angle. Okay. Or let's say a different side, let's take AB. If you produce AB, one second. If you produce AB, that means you extend AB like this. The angle that it produces, this is also an exterior angle, right? Or if we take another example, let's say you extend the CA side, this is also another exterior angle. So exterior angle basically means when you extend the side of a triangle, the angle that it forms is called the exterior angle. Is that clear, Lamai? Is that clear? Yes. So all three of these are exterior angles. Now we'll talk about the theorem. Exterior angle formed when a side of a triangle is produced is equal to the sum of the two interior opposite angles, right? So for this, I will draw another triangle like this. Let's say in this triangle, this side is produced. We have, let's say, P, Q, R, and then when we extend this, let's say this is S. So we know very well that PRS, that means this angle is an exterior angle. So PRS is an exterior angle. According to the theorem, this is equal to the sum of the two interior opposite angles. What that means is, if you take this exterior angle, the angle that is interior to this is this. මෙයාට interior ඉන්නේ මෙයා. Right? එයා නෙවෙයි අනිත් දෙන්න. That means this and this. Okay? Therefore, when you take an exterior angle, that is equal to interior opposite angles. But not this one. Nah? You cannot take this one. If you take an exterior angle, the angle that is immediately interior to this, you cannot take. The other two angles is what we are going to use, right? Therefore, this exterior angle PRS is equal to this angle, which is PQR, plus this angle, which is QPR. Is that clear, Lamai? Is that clear to all of you? Okay, others? All right. So that is the first theorem. Can you all quickly copy this down? Then let's do some example questions. Quickly copy this down, make it fast. Others done? All right. Now let's do some example questions. So for examples, I'm going to use the same examples as on the textbook, but we will discuss it on our own. First one is this diagram. So you all don't write it for now. Just listen to what I'm doing and just look at the board. And once we finish discussing, I will give you time to write. Now, according to this question, we have to find the magnitude of ACB. Find the magnitude of ACB. This is our first example question. Okay. Now here we can see that this is an exterior angle. And it's equal to the sum of the two interior opposite angles. So at interior opposite in this one and this one. Right? So I'm going to write like this. BAC plus ACB is equal to ABC. Sorry, ABD. You know in geometry, I have taught you this previously also. Whenever you write something, you have to write the reason within brackets. Right? So what is the reason here? You write the reason as exterior angle equals sum of interior opposite angles. Instead of angles, you can use the angle sign, right? Angle symbol like use karna puluwan. Excuse me. Okay. So let's see. BAC value I already know, but I can see it here. BAC is 60 degrees. ACB I don't know. ABD is 110 degrees. So ACB means 110. This 60, I bring it to other side, it becomes minus 60. So ACB equals 110 minus 60. That would be how much? 50 degrees. Then that is the value of ACB. Did you all understand this, Lamai? Others? Okay. Don't write yet. Let's discuss example 2 as well. Then this is example 2. The question here is, based on the information in the figure, find the magnitudes of AEB and BCE. Let's see. Where is AEB? AEB in methana. That is X, right? BCE is Y. So we have to find X and Y basically. Okay. If you consider this triangle, can you see that X is an exterior angle there? Right? If you consider AED triangle, X is an exterior angle. Okay? So, I will write that when you consider AED triangle, we can see that X is an exterior angle and we know exterior angle equals sum of interior opposite angles. Therefore, X is equal to 25 plus 70. You have to write the reason, so I will write it. Exterior angle equals sum of interior opposite angles. So we know 25 plus 70 is 95 degrees. Since X is 95, we know X is AEB. Therefore, we can say AEB is 95 degrees. Is this clear, Lamai? Others? Thumbs up, please.
Understood, miss.
Okay. Lami, my connection, it says that it's unstable. If you cannot hear, let me know. I will keep my camera off for a bit. Okay, then we have BCE. We know BCE is Y. If you consider this triangle, we know again X is an exterior angle and X is equal to 40 plus Y, right? So let's consider BEC triangle. Here we know X is the exterior angle and that is equal to 40 plus Y. Now we already know what X is. We know X is 95, right? So instead of X, I will write 95 here, 40 plus Y. So I leave Y here. I'm going to bring 40 to the other side. Then it becomes minus. 95 minus 40 is 55. Therefore, Y is equal to 55. And we know Y is BCE triangle. Therefore, BCE triangle is 55 degrees. Is this clear, Lamai? Others?
Understood.
All right. Then let's write the examples. Example 1 and 2 both, please write it fast. And then I will give you a question to try alone. Done, Lamai?
Yes, miss.
No, miss.
Okay, I will give you like 1 more minute. All right. Shall we jump to a question? Go to exercise 8.1. Let's do 2 questions. Can you all try second and third ones? In 8.2, in the first question, can you try second and third one? Quickly try the second and third ones. You won't really need too much time. These are not very difficult, but yeah, quickly do it. Lama, have you all finished? I see that some of you have. What about others? Okay. How about I give a few, like 1 more minute? Quickly try to work it out within 1 minute, and then I'll start discussing. All right. So here we have to find the letter N, right? Letter N. Okay, let's see. We can see two parallel lines. This line and this line are parallel. Since they're parallel, you know there are alternate angles because this angle and this angle are alternate angles. Therefore, this is also 55 degrees, right? So, api muli make a liyalemu. There are no letters given. Ne? However, yes, this is 55 degrees. Now, if you check here, if you take N, right? Let me erase this color that I put here. If you take this triangle, we can see that N is an exterior angle, right? N is an exterior angle and N is going to be equal to this and this. Now we know that this is 55, but what about this? How do we find this?
Angles on a straight line.
Angles on a straight line. Since there are no letters, I will not write anything here. However, yes, it is angles on a straight line because 180 should be the total angle here and this is 100. So 180 minus 100. Therefore, this will be 80 degrees. Is it clear to all of you how I got 55 degrees and 80 degrees? Okay. Now, N is the exterior angle and N is equal to 55 plus 80. I write the reason as exterior angle equals sum of interior opposite angles. So we know that would be 135 degrees. All right. Then, did you all get this answer? All right, great. Let's look at this one. Here we have to find x. Now here there are letters in the vertices as well. So that's so much easier. Okay. If you take this triangle, we can see that 135 is the exterior angle, 45 and x are interior opposite angles. And now directly 45 plus x equals 135. Same reason. Therefore, x is equal to 135. I'm going to bring 45 to this side. Therefore, x will be equal to 90 degrees. Is this clear, Lamai? Okay. Now, in this lesson, there's a part, our next part, it's called formal proof. මම සාමාන්‍ය class එකේ formal proof එක කරන්නේ නැහැ because they never ask the formal proof. They just want to make sure that you are able to do like long geometry questions. So we will straight away jump to a little more advanced question. Okay. Let's go with this. Put example 3. Okay, based on the information in the figure, prove that BAC Canimea plus ABC Canimea that is equal to DEC. DEC Canimea. Okay. We'll see now. First of all, we can see that we have DEC here. Right? We have DEC here. So DEC is this angle. If you consider the triangle ADE, we can see that DEC is the exterior angle. Right? In the triangle ADE, the angle DEC is equal to sum of interior opposite angles. So this is one interior angle, this is another interior opposite angle. So this is ADE, this is DAE. Okay, so this is, as usual, exterior angle equals sum of interior opposite angles. Right. Now, according to what they're trying to prove, okay, DEC අපිට තියෙනවා. We need BAC, okay, and we need ABC. If you carefully see here, can you see that here DAE, here we have DAE, no? DAE is the same as BAC, right? Can you see that? DAE and BAC are the same angles. Is that clear? Can you see that, Lamai? Can you all hear me?
Yes, yes.
So DAE means this angle. It's the same as BAC. So here, instead of DAE, I'm going to write BAC. So DEC equals ADE plus BAC. Now we are almost close. We have DEC, DEC, BAC, BAC. But here we have ADE and they're asking us to show that it's ABC. So if we have a way to equal ADE and ABC, we are good. Right? Okay, let's see ABC and ADE. ADE is this. ABC is this. Do you think they're equal, Amay?
Yes.
And what could...
Corresponding angles.
Yes, correct. ADE and ABC are equal because they are corresponding angles between parallel lines. Therefore, I write ADE equals ABC, and within brackets, I write corresponding angles between parallel lines. Therefore, මෙයාවම මට ලියන්න පුළුවන් DEC I write as it is. Here, instead of ADE, I can write ABC because they're equal. ABC plus BAC. And you can see that that is exactly what they are asking us to show, no? But it's the same thing. Did you all understand how to get the answer here? Others? Okay. Can you all quickly copy this down? And I want you to try a question alone. Once you copy this down, go to exercise 8.2. And I want you to try the second question. First copy this down, then go to exercise 8.2. And I want you to try the second question. While you do this, please excuse me for like 2-3 minutes. I will be back. But meanwhile, please do this. Copy down this question. Then in exercise 8.2 on page 90, do the second question. Okay.